Hi students, in this session I am going to discuss about jet transform and inverse jet transform. Okay, how a jet transform is defined and what is the equation for the jet transform when a signal is given, how you have to find out jet transform. There is a formula for jet transform and what is the formula for inverse jet transform. Okay, I will explain all this in this class. Before going to this, first I want to give a brief introduction about this jet transform. Okay, all of you know that a continuous time linear time invariant system is described by a differential equation. And Laplace transform is used to solve those differential equations. In the same way, a discrete time linear time invariant system is described by difference equation, and these jet transforms are used to solve those difference equations. That means these jet transforms will convert those difference equations into algebraic equations and then it will simplify. Okay, simply to solve the difference equations we will use these jet transforms. Okay, simply for continuous time signals, that is continuous time linear time invariant systems are described with differential equations, and Laplace transform is used to solve those differential equations. That is, whenever there are continuous time signals, we will go for Laplace transform. If there is the discrete time LTI system, okay, so in that they are described by difference equations, and we use jet transform. To solve those difference equations. That is, simply for continuous time we will go with the Laplace transform. For discrete time we will go with the jet transform. Okay, it is continuous time Fourier transform. Okay, continuous time Fourier transform. For that we will go for Laplace transform. For discrete time Fourier transform extension, we go for jet transform. Okay, simple we remember like this. That means in jet transform we will have all the discrete signals. Hence in the last class I explained completely about discrete signals, that is discrete complex exponentials, discrete sinusoidals, everything I explained about completely regarding discrete signals. Why? Because this jet transform mainly deals with the discrete time signals. Okay, now this is the brief introduction about this jet transform. Okay, now how we find out the jet transform for a given difference equation of signal? Simple. For a given signal as x of n, we all know a discrete time signal is represented with x of n. That is, for a given signal x of n, the jet transform will be represented as z of x of n. That is jet transform of x of n, or simply we can represent as capital X of z. Okay. Whereas Laplace transform we are represented with capital X of s because it is in s domain, whereas it is in z domain. Hence we are represented with capital X of z. So that is s domain, this is z domain. So for a given signal x of n, there is in Laplace transform the signal is x of t. That is for continuous time signal. Here in jet transform we are going for discrete time signals. Hence a discrete time signal is represented with x of n. For that I have to go for the jet transform. That is jet transform of x of n. That can be also represented as x of capital Z. That will be equal to the formula for finding the jet transform of a signal x of n is summation n equal to minus into infinity. So for continuous we use the integration. So for discrete the integration will convert to summation. That is summation n equal to minus into infinity. In place of x of t we will have x of n, and here I will have z power minus n. There I will have e power minus st dt. Okay. So there we have s, here we have z. There is a 1. So finally the formula for finding the jet transform of a signal x of n is nothing but x of z will be equal to summation n equal to minus into infinity x of n z to the power of minus n. Okay, this is the formula for bilateral jet transform. Here jet transforms are two types: bilateral jet transform or two-sided jet transform, and next one is unilateral jet transform or one-sided jet transform. Okay, there in Laplace transform also we have two types, that is bilateral Laplace transform and unilateral Laplace transform. So what they did for bilateral Laplace transform, the integration limits are from minus infinity to plus infinity, whereas for unilateral Laplace transform, the limits of the integration are from 0 to infinity, not from minus infinity to plus infinity. For unilateral, it is from 0 to infinity. For bilateral, the limits are from minus infinity to plus infinity. In the same way, for jet transform also, we have two types, bilateral and unilateral jet transform. For bilateral jet transform, the summation is from n equal to minus infinity to infinity. Whereas for unilateral jet transform, the summation is from n equal to 0 to infinity. N equal to 0 to infinity. This is the only difference for bilateral jet transform and unilateral jet transform. Same it happens in Laplace transform. There also we have bilateral Laplace transform and unilateral transform. Only the limits changes. For bilateral, that is minus infinity to plus infinity. For unilateral, that is 0 to infinity. Here also the summation is from minus infinity plus infinity for bilateral, and for unilateral the summation is from 0 to infinity. Now see the formula for unilateral jet transform. So the unilateral jet transform, that is z of x of n equal to x of z, that equal to summation n equal to 0 to infinity, 0 to infinity x of n into z to the power of minus n. The formula is same, only the summation values, that is from n equal to 0 to infinity for unilateral jet transform or one-sided jet transform. So there are the two types of jet transforms. Okay, now here I am writing z. Here z is nothing but r into e power j omega. Here the z value is r into e power j omega. Okay, now consider this r as the radius. Okay, this is in polar form. So we can write or we can draw the polar plot. We can draw the polar plot as like this. So as this is in the polar form, I am writing the polar plot with the radius r and angle omega. Here z is a complex variable. Complex, that is, it has both real and imaginary. R is a real or omega is a complex argument, or simply angle or phase. So I can draw a circle with radius r and with an angle omega. As this is a polar form, so I can draw the polar plot for that equation with r as a radius and omega as the angle, as shown here. Okay, as shown here. The omega value changes, it moves around this one with constant r and it forms a circle. Okay, now if r value equal to 1, then it will be a unit circle. So the ROC of the jet transform will have an unit circle. That is, whenever we have to represent the ROC of jet transform, first we will go for unit circle. Okay, that means in jet transform representation of diagrammatic way, we have a circle with radius r. If r equal to 1, we will go for unit circle. Okay, now here if you go for the magnitude of this r, magnitude of this jet, mod of z will be equal to r. So here r is nothing but mod of z. Are you clear? So first I explained what I had given the equation for finding the jet transform of signal x of n. There were two types of jet transform, bilateral and unilateral. So in this there is a term called z. Here the z is nothing but r into e power j omega. So this is of polar form. Now I can draw the polar plot with radius r and angle phi. Okay, now if you want to go for the magnitude of this z, that will be equal to r. So magnitude of this z, mod of z, will be equal to r. Okay, now the ROC, the region of convergence of this jet transform, is mainly dependent on this mod z, that is this r value. Okay, that is, r is the radius of the circle. So the mod z value either greater than 1, then it is outside, the ROC is outside. If the mod z value is less than 1, then it is inside this. If mod z is greater than r, that is outside the circle of radius r is the ROC. If mod z is less than r, then the ROC is inside the circle. Where in Laplace transform we have the strips of lines parallel to j omega axis. Here we have the circles with radius r. Okay, generally for r equal to 1 we go for unit circle. Okay, generally the ROC of this jet transform will represent with unit circle. So here in jet transform we'll have these circles. Okay, based on the circles either outside or inside or the combination. Okay, we will get this ROCs. I will explain those clearly when I got to the topic of region of convergence. Now, see jet transform and inverse jet transform. How can you get the inverse jet transform from jet transform? Already you know the formulas for jet transform. Okay, so I'm using this bilateral because it has both complete from minus infinity to infinity. So using that, I will find out the inverse jet transform. Okay, so next topic I'm going for inverse jet transform. See, we all know the formula of jet transform, that is x of z will be equal to summation n equal to minus infinity x of n z to the power of minus n. This is the formula, and we know r value will be equal, sorry, z value will be equal to, and we know z value is equal to r into e power j omega, r into e power j omega. So x of r into e power j omega will be equal to, just substituting if z equal to r into e power j omega, then substitute z equal to r into e power j omega in this equation. So x of r into e power j omega equal to summation n equal to minus into infinity x of n, in place of z I have to substitute r into e power j omega whole power minus n, whole power minus n. Now that will be equal to summation n equal to minus into infinity x of n, see, separating this one, r to the power of minus n and into e power j omega, that is minus j omega n, e power j minus j omega n, separating this one, applying minus n to this one, applying minus n to this one. See, now x of r into e power j omega, nothing, r into e power j omega is nothing but z. So x of z, this equation will be equal to, see, what is the discrete time Fourier transform? Discrete time Fourier transform. So discrete time Fourier transform is nothing but summation n equal to minus infinity, that signal into e power j omega n, that is the discrete time Fourier transform of signal. Okay, now here if you consider this as a signal, then for this the Fourier transform will be equal to, Fourier transform is nothing but this, for this the Fourier transform is nothing but, so the Fourier transform of x of n into r to the power of minus n. Simply the Fourier transform of x of n is summation n equal to minus infinity to infinity x of n into e power minus j omega n. So in place of x of n I have x of n into r to the power of minus n. So any signal, if you go for the summation from n equal to minus into infinity, that signal into e power minus j omega n is nothing but the Fourier transform formula, discrete time Fourier transform. So here I am going for discrete time Fourier transform. So continuous time Fourier transform we gone for Laplace transform, whereas discrete time Fourier transform will go for jet transform. Okay, now this is the formula for discrete time Fourier transform. I simply write Fourier transform because jet transform is for discrete time signals only, hence I written just Fourier transform. There is a Fourier transform, discrete time Fourier transform of x of n into r to the power of minus n. Okay, now if r equal to 1, I said unit circle, if r equal to 1 to the power of minus n, there is 1, then the jet transform is equal to the Fourier transform. So if r value equal to 1, then jet transform equal to Fourier transform. If r equal to 1, what is the value of z? If r equal to 1, the value of z will be equal to e power j omega. That is, whenever z value will be equal to e power j omega, then jet transform will be equal to the Fourier transform. Okay, that is x of z at z equal to e power j omega, I can write that as a Fourier transform of x of n. So jet transform is equal to the Fourier transform. Jet transform is equal to the Fourier transform when r equal to 1, or simply z equal to e power j, or simply discrete time Fourier transform of x of n will be equal to jet transform x of z at z equal to e power j omega, because r equal to 1. R equal to 1 means z equal to e power j omega. So this is the relation between jet transform and Fourier transform. That is jet transform and discrete Fourier transform. So relation between jet transform and Fourier transform is this one. Fourier transform of x of n will be equal to jet transform at z equal to e power j omega. So I shown you the relation between Fourier transform and discrete Fourier. Sorry, I shown the relation between jet transform and discrete time Fourier transform. Okay. Now we move on to the inverse Fourier transform. How you have to find out the inverse Fourier transform? We will see it now. Okay, see, we know the equation for x of r into e power j omega. X of r into e power j omega is nothing but the Fourier transform of x of n into r to the power of minus n. So Fourier transform of x of n into r to the power of minus n is x of r into e power j omega, nothing but x of z. So the z transform is nothing but the Fourier transform of x of n into r to the power of minus n, and in place of z I substitute r into e power j omega. Okay. Now, if this Fourier transform comes this side, what happens? It becomes as inverse Fourier transform. So x of n into r to the power of minus n, x of n into r to the power of minus n will be equal to inverse Fourier transform of x of r into j omega, x of r into e power j omega, x of r into e power j omega. Okay, just if comes this inverse Fourier transform. Now, see, x of n equal to, this is r to the power of minus n, that is 1 by r power n. If you go this side, it will become r power n. So x of n equal to r power n into inverse Fourier transform of x of r into e power j omega. Just r power minus n, that is 1 by r to the power of n. It multiplied to the other side, r power n into this one. Now, what is the formula for inverse Fourier, discrete time inverse Fourier transform? Simply the formula is integral minus pi to pi, the signal that is x of r into e power j omega, whatever there inside, into e power j omega and d omega. So this is the inverse Fourier transform formula, a discrete time inverse Fourier transform formula. So r power n same, and I use the formula that is 1 by 2 pi into integral that one, what is the signal, into e power j omega and d omega. Okay. Now bring this inside this integral. So 1 by 2 pi integral x of r into e power j omega r to the power of n. So I kept here r to the power of n, r to the power of n into e into j e power j omega n. So here r to the power of n, here also we have e power j omega n. So I combine it written as r into e power j omega whole power n, that is r power n into e power j omega n, same as. So I read it combinedly. Why? Because r into e power j omega is equal to z. For that reason I don't write r to the power of n into e power j omega n. I combine it as r into e power j omega whole power n, like this. Okay. Now we know that r into e power j omega equal to z. So in place I can substitute z. In place I can substitute z. Now whenever this is this one, so we have to go for differentiation with respect to omega, dz by d omega. That is same, r into e power j omega, r into e power j omega. So we are differentiating with respect to omega, means j comes here. So j into r into e power j omega d omega equal to dz. Simply d by dz we have to find out. So with respect to d omega, hence I have written z first, and r into e power j omega into d omega equal to dz. Now r into e power j omega is z. So j into z d omega equal to dz. Now I need d omega. So d omega equal to dz by j into z. dz by j into z. Or you can write 1 by z equal to z inverse. So 1 by j into z inverse into dz. This is the formula for d omega. Whenever we substitute r equal to e power j omega, in place of, whenever we substitute r into e power j omega equal to z, in place of d omega I have to write 1 by j into z inverse into dz. Okay. Now substitute these two in this formula. Now what is the formula for xn? X of n. X of n will be equal to 1 by 2 pi. So closed contour integral. Okay. Closed contour integral. So this integration will be for a complete cycle in contour direction. Now x of z. Why? Because in place of r into e power j omega I substitute z. X of z. Here also I substitute z to the power of n. In place of d omega I have to substitute 1 by z into z inverse into d omega. 1 by z into z inverse into d omega. So I bring the j outside the integral, that is x of n equal to 1 by 2 pi z closed contour integral. So this contour integral x of z power n into z power minus 1, simply z power n minus 1, z power n minus 1 into d omega. So this is the formula. This is the formula for finding the original signal x of n. That is formula for inverse Z transform. Inverse Z transform. Okay. So simple. Here first I taken the Z transform, and then I know the value of Z. I substitute it and I converted it into discrete time Fourier transforms. Okay. Now after that I gone for the relation between Z transform and discrete time Fourier transform. After that I use the concept of inverse Fourier transform. I use the formula of inverse Fourier transform, and there also again I substitute r into e power j omega equal to z and gone for some simplifications and substituted those values in the given equation, and finally I got the inverse Z transform as 1 by 2 pi j into contour closed integral x of z to the power of n minus 1 d omega. So this is how to find the Z transform. inverse Z transform equation from Z transform. So from Z transform, I find out the formula for inverse Z transform. So finally, I given the equations of Z transform and inverse Z transform. So the Z transform of a signal x of n is given as x of z equal to summation n equal to minus infinity x of n z to the power of minus n. So this is the formula for Z transform. In the same way, the formula for inverse Z transform is x of n equal to 1 by 2 pi j into contour closed integral x of z into z to the power of n minus 1 into dz. So this is the formula for inverse Z transform. Inverse Z transform. So in this class, I explained you the introduction or the basic concepts of this Z transform, introduction to the Z transform, and then formulas for Z transform, that is for both bilateral Z transform and unilateral Z transform, and next I gave you the formula for inverse Z transform. Okay, I explained the procedure to find the inverse Z transform. Okay, these are the topics that I explained in this class. With this, I am finishing today's class. Thank you, one and all.